This is a setup video for the Magnetic Fields and Forces lab. In part 1, you're going to look at the magnetic field created by a current carrying wire. So what you're going to need for this part is you're going to need your iLab device, which you used last week, and you're also going to need to make sure that you calibrate the magnetometer sensor. So in the iLab setup document on Moodle, there's a link to a video on how to do that. So you're going to want to make sure you do that before you start collecting any data. All right. Then to form a straight wire, we give you a spool of magnet wire that is 1 meter long. So a couple of you might have gotten it not in a spool, but just in a plastic bag, but the same thing. So take that off, and then we're going to form a straight piece of wire out of this. So we'll just take part of it, kind of straighten it out, and it likes to go all over the place. So if you take a couple pieces of tape, you can tape it down so it's out of your way and ready to take some data. Okay, and your magnetometer sensor on your iLab device is labeled here with an M. So we're going to place it as close to the wire as we can get it. And then we want to find the current going through the straight part of the wire here. So we're going to try to get these other parts of the wire as much out of the way as we can so it doesn't interfere with the reading from this part of the wire. So we'll just plug these into the positive and negative of the breadboard, and then like last week we'll plug the battery pack into the positive and negative on the breadboard as well. This time we'll use the 2 AA battery pack. Alright, so the 9 volt will be a bit too much for this experiment. We don't it'll make the wires a bit hot, so we don't want to get anything burned. Plug those in, and then you're basically ready to go. So to get the current flowing, you turn the switch on the battery pack, right, and then you can collect your data. And basically you're just, in this part, you're just going to measure the magnetic field created by the straight wire at 1 centimeter increments. Okay, so if you have a ruler or something, you can measure out those 1 centimeter increments. Just make sure that you don't keep the battery pack on for too long. This wire will get hot. So switch that off. Then in the last part, last step of this part, you want to switch the polarity. So basically all you got to do is reverse the wires coming from the battery. So normally we have the red going to positive, and you can feel that these wires are hot right now. And the black goes to negative. We'll just switch those, so there's nothing wrong with that. All that does is switch the direction that the current flows from the battery to the wire. And then you'll use the magnetometer sensor to measure the magnetic field coming from the battery now that we've reversed the polarity. In part 2, we're going to look at the magnetic field created by a coil of wire. So we have this spool that says 3M. That means it's 3 meter length piece of wire. So we'll go ahead and unwrap that, and we're going to make a coil out of this wire. So to make the coil, straighten this out a bit, I gave you this clear plastic tube, and I don't want you to wrap it right around the tube, but I want you to wrap it maybe around the tube and a pencil, or the tube and the cow magnet that we gave you. This way, when you go to use this coil next week, you will use the coil that you make for this lab. You will use it in the following lab as well. So you will have to put the coil back onto this plastic tube and move it around in different positions on the tube. So if you wrap it, the coil just on the tube itself, it'll be too tight to slide back on, and you'll have to remake the coil. So it'll be a lot easier if you just make the coil a little bit wider this time. And as you do this, 4, 5, 6, count the number of turns on each coil. You're going to need to know that. Alright, then I'll slide my magnet out, or pencil, whatever you used, and then I'll slide off nice and easily, and then you'll basically have something that looks like that. If you want to be fussy, you can turn it into a nice circle, and then you'll have two ends that are ready to go and take measurements of the coil. So to set this part up, you'll have your breadboard again, you'll have your battery pack connected positive to negative, and then we're going to place the coil so that the center of the coil is over the magnetometer. And then I'll plug in one end of the coil right into the positive on the breadboard, and the other end I'm going to connect with one of these wires. You got two of these. May have gotten different colors, but they have these plugs on one end, and these are just alligator clips covering the plugs. You can take them on and off as you need. So we'll take one of these with the alligator clip, and we'll clip it onto the other side of the coil. And then if the coil is moving around a lot, you can tape it down on there to keep it still. Alright, then we'll plug this into the multimeter. We'll plug it into the top hole there. And then we'll take the other one of these wires and plug it into the bottom hole. And then we'll grab a jumper wire and clip it to the alligator clip, and then we can plug the other end into the negative of the breadboard. Alright, then we'll go ahead and turn the multimeter on to 10 amps over here. And then once you go and turn the battery pack on, you'll actually start seeing some current flowing through there. Okay, so don't keep that on for too long. That's a lot of current going through there. And then now you can go ahead and take your measurements of currents and magnetic field strength. Then for the last part, you have this mystery coil, so we just kind of wrapped it up in electrical tape. You're going to devise a way to determine how many turns are in this coil. And that's it for Lab 3.